Greetings and welcome. In this session, we will see how to solve a numerical on equivalent diameter of circular duct or rectangular duct. Now, in this numerical, there is a formula required, that is of equivalent diameter. The concept is a separate video on the derivation of equivalent diameter of a circular duct and rectangular duct, which you can see in the playlist. Now in this case, here is a numerical given. In this we have to find the diameter of rectangular duct, means given diameter given is a circular duct, dimension of circular duct is given, and then by using the concept of equivalent diameter concept, we have to find the size for the rectangular duct. So for this, let us see the statement given here of the numerical. So in this statement, a circular duct of a 40 centimeter diameter is used to carry air in an air conditioning system at a velocity of 440 meter per minute. Here, dimension of circular duct means diameter is given in a centimeter and velocity of air is given in meter per minute. If this duct is to be replaced by a rectangular duct of aspect ratio is given here 1.5. Find out the size of rectangular duct for equal friction method when. Now here are the two conditions normally we use in equivalent diameter concept. First, when the velocity of air in two duct is the same, and when the discharge means volume flow rate of air in the two duct is the same. So we will have two sets of calculation for these two conditions. Now for this pipe, F is a friction factor is given, and we are asked to find out the pressure loss per 100 meter length, because by the calculation we will find the pressure loss that will be for 1 meter. Here the length of pipe is given, that is 100 meter. And density of air is provided here 1.15 kg per meter cube. So let us to start, first of all enlist the data which is given here. So here is the data enlisted. Given is a circular duct, diameter 40 centimeter. Now in this in any numerical, we have to convert all the dimensions in meter. We have to bring all the dimensions whatever are given, these are to be brought in a meter. So that is why here 40 centimeter in a meter, that is a 0.4 meter. Velocity is given, this also we have to convert into meter per second. So 440 meter per minute divided by 60, that we will do in a calculation. Now aspect ratio means what? A by B. So this is given 1.5. So this will be used when the size of one of the sides is to be calculated, friction factor and density. So now we will go step by step. First we will do the calculation for case 1, means when the velocity is the same. When the velocity is the same, this is a standard formula we find from the derivation, that is a D is equal to twice AB divided by A plus B. Now here we have to obtain value of A and B, and both are unknown. So that is why here we have to eliminate one of them. So that is why we do the arrangement. That arrangement is what? We take common B from the numerator and denominator. So numerator, if you take B inside the bracket, 2A remains. Outside here below at the denominator, if you take here common B, then inside this what will come? A by B plus 1. So B get cancelled. So we find this expression. Now in this expression, now we can put A by B, that is aspect ratio given value, that is 1.5. So 1.5 will be here. Diameter D, that is given 0.4. So we can calculate now A, value of A. So in the next case here we can see this is a diameter 0.4 twice A divided by aspect ratio 1.5 plus 1. So here by doing this step calculation, we find the smaller longer side of the rectangular duct, that is A in a meter. By using this aspect ratio, A by B is equal to 1.5, we find the other side of the duct B in a meter. So thus, as in the statement size of the duct is mentioned in a centimeter, that is why we have converted these sizes in a centimeter. Otherwise, if you mention as it is, then also no problem. Okay, so here first case output of the problem, that is a size of the duct rectangular for case 1, means for velocity same, is completed. Now the second case where the velocity discharge is the same. So for same discharge, here this is a standard formula. This is the outcome of the derivation of equivalent diameter for the duct when the volume flow rate is same. So that standard formula is directly we have used here. D is equal to 1.265 bracket a cube b cube divided by a plus b bracket complete raised to 1 by 5. Now in this case, here we have to again use a trick in order to eliminate one of the size. So here, as a by b is equal to 1.5, so a will be equal to 1.5 times b. So what we do, at the place of a, here and here, we put 1.5 b. So here 1.5 b whole bracket, then cube, here is a b cube divided by 1.5 b plus this is a b. So that is why here in this way, the next step, that is what, cancellation of the terms and putting the values. So by the cancellation of term and putting the values, we find the sizes for the rectangular duct, that is A and B, both in centimeter are expressed here. Now the next one is, we are asked to find pressure loss per 100 meter length. Per 100 meter length, so here is a formula, that is a pressure loss PM is equal to FL rho V square by 2M. Now here we have to find M, means hydraulic mean depth. For that, area by perimeter, area is a pi by 4 into d square, because the given is circular duct, divided by perimeter for the circle is pi d. So by cancellation of term, we find d by 4. Putting the value of diameter of circular duct 0.4. Here we find value of M. Now this value M we use in the calculation. So F, that is a friction factor given, is mentioned. Length we take 100 meter because it is asked for 100 meter. Here rho A, density of the air 1.15, and velocity 440 meter per minute is mentioned. So that we have to convert into meter cube per second. Meter per second. So that is why this, we divide this 440 by 60. And here is a velocity square divided by 2 into calculated value of M, that is 0.1. So by putting all these value and doing the calculation, finally we get the value of PF, that is a pressure loss due to friction in a Newton per meter square. So in this way, we have seen how to find the size of duct for the rectangular duct. If the circular duct is given and we are asked to find the size for rectangular duct, then by using the hydraulic mean diameter formula for the case 1, that is when the velocity is same, and case 2, that is when the volume flow rate is same, that we have seen. So let us meet in the next video session. Thank you.